Well, hello everyone, and welcome back to Chapter 2 of how to build a custom set of hickory golf clubs for someone. If you recall, at the end of Chapter 1, we had selected our heads to make our set, and it wasn't what you think about in being a match set, in that it was not a contiguous set by one manufacturer and they were all the same head design. We had actually gone through and picked head designs because of where they would be played in the set. I had put flanged clubs with a broad sole into the scoring positions. Mid and longer irons, I'd gone with muscle backs, or what we call diamond backs, which are, a lot of meat behind the hitting area. This club set's going to a better player, so he'll really be able to take advantage of that. I'd also gone through and selected heads so that the weight would fit into where I needed it. I'm trying to look for 8 grams per head separation, with the heavier being better. And I started with a niblick and worked my way back, and I picked heads of the design I wanted that met the weight requirements, or that I could modify a little bit and get to the weight requirements. In Chapter 2, we're going to focus on the shafts and how to get the shafts set up to play in the set where I need them to play. Now, there's going to be a couple of elements to that. We've got to get the shaft down to the correct stiffness, and I use a frequency meter and go with cycles per second to achieve that. I also try to get the shaft to where it is flexing where I need it in the set. I like a higher flex point in the scoring clubs to give more control, and maybe a lower flex point in the longer irons and all to help get a little whip at the bottom, get the ball up, and add some spin to it. So those are the considerations that I'll walk you through, and we're going to take it step by step on how to do this. Now, I have shafts that were supplied to me by Tad Moore, and Tad was kind enough to supply them heavy. In other words, very stiff, because that's what I like. Then I have the freedom to remove material to get them down to where I want to without worrying about maybe ending up with a shaft that's too soft and unplayable for who I'm working with. I maybe would start with a little less stiffness if somebody was going to be into a senior or a regular flex. But, Andy Strachan, I've talked about, my friend in Scotland, is a better player, and he's probably going to play to a stiff shaft and a modern. So I want to make sure that I kind of match that up a little bit so he's not overdriving the shaft and having control issues with it. And the first step is I've got to get this ferrule down to where it fits into the ferrule of the club I've selected. Here, once I've got this to where it fits, I can move on to the second part of it, where I will frequency it at length to see what the base number is that I'm starting off with. So if you'll give me a minute, I'm going to take one of my favorite tools, which is a handmade rat tail rasp, a very fine one. And the reason I like the handmade is the pattern is random, so it doesn't leave any file marks when you go across it. It cuts very, very evenly. And the way we're going to do this is very, very simple. We're going to put the head on it, we're going to spin it around, and then we're going to look for these dirty spots. Let me see if I can get that in camera for you. You see where dirt and marks have been left on that? We're going to take that down where those dirt and where those marks are, like in here, in the dirt, and then we're going to try the fit again. And we're going to keep doing that until it goes all the way up on there. Now, I will start just a little bit short of all the way, because I want to have to drive it on with a mallet to get it good and tight, so that I can do the second part with the frequencying and not have the head popping off on me. I'll show you that in a minute. I'll be right back once I've got this worked down and show you what it looks like. Okay, we're there. And as you can see in the camera, I've got just a little bit of gap left there at the top. I'm going to leave that for the moment. I'll take that down before I finish the club up so that I can mount the head. But that little bit of gap's going to allow me to take a rawhide mallet, which a rawhide mallet won't mar the steel of the club, and it really catches on the edges real well and helps to drive it up on there. So I'm going to pop it a few times, get it seated on there good enough that I can go and show you the next part, which is where I frequency test it. I'm going to point out at the moment, most people would orient a shaft like this onto a hickory head, in that they've got the flat spot, if you will, straight up. That way the strength of the grain is into the direction of travel, and it's going to be the most durable. But it's an incomplete answer if you ask me, and I'm going to show you why. Let me back out of here a little bit, and I want you to watch this head travel as it slows down. See, it's starting to go vertical. We can thump it, and there, as it starts to slow down, it starts to go vertical. That's one of the things I talk about when I talk about puring a shaft. Now I'm going to rotate this shaft about 15 degrees one way and try it, and then we'll see what kind of result I get and show you the difference. All right, I'm back. Now, let me show you the difference. As you can see, I have rolled that about, let me get it to focus on it. There we go. I've rolled it about 10 to 15 degrees forward so that it's not straight on top anymore. Now, let me show you the difference this makes in the head travel. Well, I guess I need to get a better angle on it so that you can see that it's actually moving straight back and straight through now with very little up and down to it. That's what you're after. And I will mark this so that I know that that goes up that way when I go to actually shaft it. I am going to recheck it after I turn the shaft down to the frequency though, because it could change on me. So we're ready to frequency the shaft. And if I can get the camera to focus, there's the mark at length. I marked this club for the length I want it to do. I don't want to cut it off yet because I want that piece to hang on to if I need to later. But I do have it at the back of my vise, and that's a 4-inch set of jaws. That's the standard for doing this. Now, give me a minute. I'll come back with the camera set up so that you can see me use the tachometer that I use that's used for doing the RPMs on drive shafts and car engines. Tachometer off of eBay or Amazon. These things are anywhere from $10 to $30 depending on what you want to spend on them. It's just a digital tachometer. As I said, I find it picks up without having a piece of metal on it, which they talk about using when they include it with a bunch of reflective strips. But we're going to hold it underneath the shaft so that the laser beam coming up off of it that you can see there actually gets broken when the shaft goes back and forth across it. There we go. And we've got a reading of 767, and I'll explain that in a moment. We're going to do that about 4 or 5 times when the head's not coming loose again on me. And see if we get 776. No, nothing then. 771. So we were getting around 770 to 775. We'll take and divide that in half. So we end up with 350 from the 700, then 35 more, we're at 385. And that's the frequency of this shaft right now at that length. I need that way down. I've got to take like 30 cycles per second off of that to make it work for me. And because this is a scoring club, I'm going to set it up where the bend is going to be back in here towards the midsection more than up here towards the tip. I'll show you that setup in just a second. As you see, I've set the shaft up in my machine lathe, and I know I've got some machining buddies that are going to freak out with me running wood in it. And I realize that not everybody has access to this type of equipment. You can do the same thing by hand, but it is going to take you a minute. So I'm just going to fire up real quick and show you what I'm going to do. I'm going to be sanding on this shaft with 80 grit sandpaper, and you'll notice I'll start taking everything down evenly, but then I'll start working as I start pushing down on the shaft. I'm going to start looking for more movement in the middle than maybe I get towards this end. Let me fire the machine up. It's going to get a little noisy. Now we're going to be turning this at about 1,000 RPM, so it takes a lot of off of it in a quick period of time with 80 grit paper. Now the sandpaper I'm using is 80 grit, kind of a mesh by SandNet. I like this because it doesn't load up on me, and I wrap it around anything kind of spongy to kind of make an impromptu sanding sponge. And after you've done enough of this, you can actually start to feel the shaft flex under your pressure, and you know that you're starting to have some effect in taking some of the stiffness out of it. But I have a lot of control over where exactly I want to take material from. Anyway, I'm going to do this for a minute. I'll come back to camera once I get this down to where it's in the finishing stages. It just then, and I'm within 10 cycles of where I want to be. It was measuring 710, 715-ish. Half of that's going to come in at 355-ish to 360. Now I don't want to take any more off with the 80 grit. I'm going to swap sandpapers so that I can take some of the rings out that I put into it with the 80, and then I'll inline sand it along with the direction of the grain, and that will take out any marks that are left in it. So it's simply going to be me taking and going up and down the shaft this way. Not going to be much to watch as I take it out. But these rings that I have in here from the other sanding will disappear for me. I won't sand it past about probably 320, 200 to 320, simply because if you take it to 400 and 600, you tend to close the grain and the stain won't take like it ought to. So this is ready for me to kind of finish out a little bit. Once it's finished out, I'll move to the next step, which is going to be to shape the end of it down at the bell, and then cut the shaft and shape that end of it. Okay, now I'm ready to fit the bell to the neck. And because these clubs heads are from different manufacturers, they're going to vary some on me, so I can't just cut one standard thing. So I really want to do this in reference to the club head I've got. I want to leave a little bit of wood proud here. It'll protect that neck on that club and keep it from damage or getting knocked out of shape or anything else. So I'm going to take this down just a smidge, then I'll work the hump here down just a little bit by hand and sand it, and then show you what we have when we're done with it. So as you can see now, I've got a lot less hump here. That's just my personal preference. There was nothing wrong with the way it was before, but I like to kind of have that a little bit more gradual in transition. And I've taken it down now to where it's just wood sticking barely past the metal on this. Overall, I'm very, very happy with that fit. It is wood. It is a bunch of 100-year-old metal, so you're going to be able to get it close. You'll never get it exactly perfect, but I'm happy with that. Now I'll move to showing you how I cut the shaft to length on the backside and round the top of that shaft off. I'll show this a little bit on camera, but there's nothing magical about this. I'm just going to cut out past my finish line to give myself some room, and I'm going to use just a small cheap handsaw to cut it off. I don't like trying to cut it off the machine. It's too easy for it to catch and grab. This will only take a second. There we go. I can remove that piece, set my saw aside, and now I need my carriage back down here, because we're going to use this for a second to kind of true that up on the end to make sure it's perfectly 90 degrees. Not really necessary, but if you got the stuff to use it, why wouldn't you do it? And we have the stuff to use it here. Let me get that tight real quick. There we go. And we're just going to spin this down, truing it up as I go till I get down to my line. And there we go. I've cut it down to the line. I'm nice and flat across the top. Now I'm going to grab a mill file and just round that and set that bevel on the edge of that I like, which is about 45 degrees. And there we are, done. I will try to get a little closer so that you can see that and see the edge on that. Pretty nice. I can do that all day long. They'll all come out nice and even. And that kind of finishes us up for chapter 2. This shaft is ready to have the iron, or it'll be stained and all that and sealed up. But pretty much it's done and ready. I've only got like 8 more of them to go, right, for the rest of the set. So once I'm done with all the shafts, we'll pick up with chapter 3. Thank y'all for your time. Leave your comments below. If there's anything you've got questions on or need clarity on, talk to me about it. Happy to engage and share what I know. Or in some cases, reveal how much I don't. Y'all take care and have a great evening.